right, our first couple of problems do not have any context to them. So this is kind of what we did on Friday, but you're just not given the graph. So write the trig equation for the function with a period of 6. So we can just start right there. 6 has to equal 2 pi over b. So b is equal to 2 pi over 6, which is pi over 3. So we have b. The function has a max of 3 at x equals 2 and a low point of -1. So remember, I always like to find the midline first. So that's the average of the max and the min. So we're adding max and min together and dividing by 2. 2 divided by 2 is 1. So that's the value of D. Midline is at 1. And then let's graph what we have. Well, we could also find A. You might want to sketch the graph first, but the midline to the maximum, 3 minus 1, that's a midline of 2. So, that's a distance of 2. So A is equal to 2. And then as far as phase shifts, we'll look at that once we get the graph. So when I sketch a graph, we're so used to doing X and Y axis, but I like to just label this as the midline here. So here's 1. And then we have a max of 3 and a minimum of -1. All right, so at x equals 2, the graph hits 3. And then I know this is sinusoidal. I guess it doesn't say in the problem, but that's what this worksheet is about. So I'm not too worried about, I try to equally space these. I'm not worried about labeling every point. I don't necessarily want to take the time to do that unless I'm told I have to, but I can get this image of the sine curve. So now I can see a phase shift I said sine curve, I meant cosine curve. So if I'm looking at this section of a cosine curve, we've gone to the right 2 units. So C is -2. If I look at this as a sine curve, and remember, I want you to do both because sometimes on the AP problems, I've seen that we have freedom to choose, and sometimes we're told to make it into one or the other. So we need to be able to do both. So this sine graph would be shifted how far over? Remember, you can always take the period and divide it into 4 equal parts. So this point is at 2 plus the period, which was 6, divided into 4 equal parts. 2 plus, this is 1.5, so that's at 3.5. That's where that point is right there. So the sine curve would be shifted to the right 3.5 units. Negative because we're shifting to the right. So we have both of those. And now we have enough to write the equation. So I'm just going to say for the cosine curve, y equals, it's a positive cosine curve, so the amplitude is 2. Cosine b is pi over 3. Always write it in this factored form, x minus 2 plus 1 for the midline. If we had to write this as a sine curve, it would be y equals the sine curve that I picked that's been shifted, that starts at 3.5. It opens down, so it's -2. Sine of pi over 3, same period, x minus 3.5. Sorry, x minus 3.5. I wrote that down wrong over there. Midline is the same. So remember, when you're doing these, sine or cosine, midline's the same, b is the same, amplitude can change only by a negative, and it's the c value that's completely different. All right, for number 2, write the trig equation for a function with a period of 5. So 5 is equal to 2 pi over b. B is equal to 2 pi over 5. Low point of -3 at x equals 1, and an amplitude of 7. So they tell us A, amplitude is 7. I have the minimum. Maybe you want to sketch the graph at this point. I don't know the midline yet. I do know that at x equals 1, we hit a low point of -3. The amplitude is 7, so if you add 7 to that, you land at a midline of, this is going to be way off scale here, 4, right? So amplitude is the distance between midline and the low point, or midline and the high point. So the midline is at 4, so there's D. The high point then will be at like 11. I probably don't need that, but the rest of this I'm just going to say, okay, and then we hit midline, and then we hit the max, and then we hit midline, and then we finish where we started. This looks like a negative cosine curve to me. What about the phase shift? So for the phase shift, let's start with cosine because it looks like cosine. So that's gone to the right 1 unit. So C is going to be -1. If we're talking about sine, that would start right here. What is this point? This point is 1 plus every point is a fourth of the period. So the period was 5. Pen stopped working. Just a minute. Put this back in for a quick connection. Okay, so the period is 5, and you divide it into 4 equal parts. So there's 1.25 units between. Oh, sorry, between between this point. I put my arrow to the wrong point. Sorry, this point is 1 plus 1.25. So 1 plus 1 and a fourth is 2 and a fourth. So C is -2.25, or you can make that a fraction, whatever. The only time I say don't use a decimal is if the decimal is not terminating. We don't want to use rounded values in our equations. All right, so we have A, B, C, and D, and now we can write the equation. So the cosine equation is a negative cosine equation, so -7 cosine of B, 2 pi over 5, times the quantity x minus 1 plus 4. And the sine equation would be y equals, it's a positive sine equation here. So 7 sine 2 pi over 5, x minus 2.25 plus 4. Number 3, I had some information about this on the board because I think this one's kind of confusing if we're not all that familiar with blood pressure. So Ruby has a pulse rate of 73 beats per minute. Now, that is a period because it's talking about per 1 unit. So the frequency is 73, and that means that the period is 1 over 73. So if we set that equal to 2 pi over b, then b is 2 pi over 1 over 73, really 2 pi times 73, so 146 pi. So that's b. Blood pressure is 121 over 85. So again, I had this on the board too. That means that the max is 121 and the min is 85. And so we can find the midline if we add those two together and divide by 2, because the midline is the average of the max and the min. So what is this? 206 over 2. So that would be 103 is our midline. All right, and then I can't do phase shifts yet. I could do amplitude. A is the distance between the max and the midline, or the midline and the minimum. So what is this a difference of? 18? So A is 18. If it helps you to see, to graph first, you could do that too. So let's graph what we have. Now, here's the last thing. I had this on the board too, because again, I don't think this is very obvious either. We're assuming that the blood pressure at the beginning is at the midline, and then it hits its max, and then it hits the midline, min, back here. So we're assuming at time equals 0 is when this starts. So we have a sine curve. We can label stuff in if we want to. Let's start with that. If it's a sine curve for the phase shift, there's no phase shift. So if it's sine, C equals 0. What if it's cosine? If it's cosine, I need to figure out, I would start here and say, here's my cosine curve. So this is the period, which is 1 over 73 divided by 4. 1 over 73 times 1/4. So 292. 1 over 292. I was going to hop over to my calculator because I have it, but then I realized we can probably just do that math. So, okay. So it's to the right if it's cosine. So minus 1 over 292. And that is enough to write the function. So y is equal to, if it's a sine function, our amplitude is 18 sine of 146 pi t minus 0 plus 103. And if we choose to make a cosine function starts above amplitude, so or above midline, so 18 cosine 146 pi. We said this will be t minus 1 over 292 plus 103. And that's all that we're asked to do for this problem. For number 4, we had a spring like this in our notes, but now we have to provide the graph. So a mass is suspended from a spring. A mass is pulled down a distance 2 feet from its rest position. So mass is released at time 0 and allowed to oscillate. So let's just start here. Here's midline. Mass is pulled 2 feet below its midline at time equals 0, and then it's let go. So it's going to hit midline, back up, midline, back down. If the mass returns to this position after 1 second, find the equation that describes its motion, and then find at what 2 times within 1 cycle is the spring at 1.5 feet above its rest position. So let's say rest is 0 because they didn't give us a height above the ground or anything. That means that this is -2 and the max is 2. So we have a little cosine looking curve here. So the midline is 0. The period is equal to 1 second. It takes 1 second to return to its starting position. So if that's equal to 2 pi over b, then b is 2 pi. If we're looking for a phase shift, what about amplitude? Amplitude is 2. I can see that from the graph. It's also how far down we pulled the thing. So if this is a cosine graph, then c is 0. And if this is a sine graph, I would say the sine graph would start here and go up and through. So what is this point? Well, the period is 1 divided by 4. So that would be to the right 1/4. And I have enough to write my equation. So y is equal to, for the cosine curve, -2 cosine of 2 pi times t minus 0 plus 0. I know I can simplify that, but I'm just kind of putting all the pieces in there into place. And then starting here, it's a positive sine curve. So 2 sine of 2 pi t minus 1/4 plus 0. So those are 2 options for describing the motion. And then when is this, find at what 2 times we hit 1.5 feet. So say 1.5 is like right here. It's asking us to find these 2 points. So we'll do that on a calculator. So when is 1.5 equal to either one of these equations? I'm going to use the simplest one, -2 cosine of 2 pi t. All right, so if I'm going to use a calculator to solve this, I've got to put these equations into my y equals. So one side should be 1.5. The other side is -2 cosine 2 pi x. Make sure that you're in radian mode. And then what about the graph? So you need to set the window. We know that this is from 0 to 1. X scale doesn't really matter. The y minimum needs to be anything that encompasses -2 to 2. And then you just hit graph. So we can see the point of intersection here. We go second, trace, intersect. Enter, enter, enter. So one time is at 0.385. And the other time uh, 0.615. And those would be labeled in seconds. Those are the 2 times where the height of the spring is at 1.5 feet. All right, number 5, a city averages 14 hours of, oh, this problem, okay, this problem is kind of weird the way that because they started at t equals 0. So I'm going to make a slight adjustment here, or I'm going to, oh, whatever. Let's just go through this problem. Okay. So a city averages 14 hours of daylight in June, 10 in December, 12 in March and September. Assume that the number of hours of daylight varies sinusoidally over the period of 1 year. So right there, they tell us the period is 1 year, except I made a slight adjustment. So if you use P equals period is 12, that's okay, because that is what it says. But if we think about this, it says let T be in months, and 0 is the month of January. So if January is 0, then that means that December is 11, not 12, right? Because January is the first month, but we're calling it 0. February would be 1. March, we need March. That would be 2, etc. But the problem with that is that the points that they're giving us are the midline, minimum, and all of those, and maximum. So we can't hit one of those points perfectly at 2. So anyway, all I want to say about this is that when I graph this thing, I might start with the graph. I might say, okay, let's see. We hit 10 in December. So at the end of this period, which is at December, which is 11, we hit 10. In January, because December is the end of the period, January's also got to be 10. And then in March and September, we hit 12. And in June, we hit 14. So the peak is 14. And then we hit 12. So I guess I drew my midline in a weird spot. But this is our curve, right? And so what they want us to say is, okay, March is 2, and June would be 5, and September would be 8, right? Everything's like 1 minus its month number. But the problem is there's 3 units here, 3 units between here, 3 units between here. Then there's only 2 units between there. So that's not truly sinusoidal. So I made a slight adjustment on my key, and I just did what I always do. If the period is equal to 11, I said, all right, this would be 11 over 4. That's where this point would start, because that's the midline. So, and this would be 11 over 2. So 5.5 instead of 5, right? So anyway, that's all I'm saying. Or I'm sorry, not 11 over 4. Yeah, 11 over 1 times 11 over 4, and then this would be 11 over 2, and then 3/4 times 11. Anyway, we don't have to get into all of those labels, but we do need to know what this point is. Okay, so if the period is 11, I'm using 11 instead of 12, and that's equal to 2 pi over b. Then b is equal to 2 pi over 11. I can see the midline is equal to 12, so there's d. I can also see the amplitude for my graph. It's 2 units. And then as far as phase shifts go, so if we're talking cosine, there's no phase shift. I should say phase, sorry, not C. And then if it's a sine graph, like I said, I'm calling this 11 over 4 instead of just 2. So because I just divided the period into 4 equal parts. So I'm going to say minus 11 over 4 for that. Okay, and then it comes to the equations. So we want, for the cosine graph, y equals negative 2 cosine of 2 pi over 11 t minus 0 plus 12. And if we use the sine equation, it's a positive sine equation here. So 2 sine 2 pi over 11 t minus 11 over 4 plus 12. And because I don't want to deal with the shift, when I'm making a prediction, it says, what is the average amount of daylight hours in August? So August would be, even though it's the 8th month, it would be 7. So y of 7. And I'm just going to plug into this one. So in radian mode, -2 cosine of 2 pi over 11 times 7, 7 minus 0 if you want, plus 12, 13.310. The label on that is hours. We're talking about hours of daylight. Okay, for number 6. The average depth of water at the end of a dock is 6 feet. So there's the midline. That's the average depth. Midline equals 6, so that's D. This varies 2 feet in both directions, so that's the amplitude. Suppose there's a high tide at 4 a.m., so let's graph what we have so far. Midline is 6. Vary that 2 in either direction. When t equals 4, which is 4 a.m., when we're at 4, we're at high tide, 8 feet. And then I'm just going to do the rest of the graph here. If the tide goes from low to high every 6 hours, write it says a cosine function. I think I did both. Write a cosine function describing the depth. So low to high is not the entire period, right? Low to high is 6, and that means high to low would also be 6. So like this is happening at 10 hours. This is happening at 16 hours, and it began at 4 hours. So that means that the period is actually 16 minus 4. So the period is 12. That means B is 2 pi over 12, which is pi over 6. So there's B. Cosine only. I didn't realize that when I made the key. So when we're talking about a phase shift, which is a horizontal shift for the cosine graph, that's going to be C equals minus 4. They want us to call this D of t. This cosine graph is positive, so 2 cosine of pi over 6 times t minus 4 plus 6. At what 2 times within one cycle is the depth at 5 feet? So when is d of t equal to 5? Again, that would be finding the 2 places on this curve where the graph hits 5. So here and here. Use your calculator to approximate this. So I'll need to make some window adjustments. Let's clear out what we have. All right, so one line needs to be 5. The other line needs to be 2 cosine of pi over 6 times x minus 4 plus 6. What about the window? So this window can't just go 0 to 1. I'm trying to look at the window 4 to 16 within one cycle, and I need the y minimum to go down to 4 and the y maximum to go up to 8. And I'll just hit graph. So here's what I'm looking at, and I want to find the intersection points. Scooch this to the left to find the first one. Oh, it's a nice number. So t is equal to 8. And find the other one. I guess we could have just used symmetry for that. If this is 8, the other one's going to be 12. But those would be hours. Now, it did ask for time. So if 4 was 4 a.m., this would be 8 a.m. and 12 hours after midnight, so 12 p.m. if they wanted the times. Okay, number 7. Astronomers have noticed that the number of visible sunspots varies from a minimum of 10 to a maximum of 110. So that's enough to find midline. 110 plus 10 over 2. 120 over 2 is 60. So there's the midline. And we can find A. It's the distance between midline and minimum, or midline, maximum, and midline, whatever, it's 50. So there's A. Further, this variation is sinusoidal, repeating over an 11-year period. So period is equal to 11, which is equal to 2 pi over B. So B is 2 pi over 11. The last maximum occurred in 2003. Write a cosine function. I didn't read this very carefully when I did the key. That represents the phenomenon, where T represents the year. I don't like having T be 2003. Sometimes the calculator can't handle that very well. So I'm going to say, let's let T equal 3 represent 2003. You can write yours where 2003 is what you number on the axis, but I'm just going to do this a little differently. So the midline is 60, the max is 110, min is 10. At 3, we hit the maximum. So just plot the points. 11 years later is when you should hit the next maximum. So 11 plus 3 is 14. Write the cosine function, call it n of t. So phase shift for cosine, I can see c is minus 3. So n of t is equal to 50 times the cosine of 2 pi over 11 times t minus 3 plus 60. It doesn't ask us to do anything with that, so that's it. Last problem. They're reminding us frequency is the reciprocal of the period. An electric current alternates with a frequency of 60 cycles per second. So if the frequency is equal to 60, that means that the period is equal to 1/60th, and that's equal to 2 pi over b. So b is equal to 2 pi times 60, which is 120 pi. This is called, quite aptly, alternating current, and is the type of electrical system we have in our homes and offices in the United States. Suppose that at t equals 0.01 seconds, the current hits its max of 5 amps. If the current varies sinusoidally over time, write an expression for I as a function of t. All right, now they don't give us a minimum, but we do have to think a little bit about this. We're not going to have electric or a negative amount of electricity here. We're going to say that the minimum will be 0. So if the max is 5 and the min is 0, that means that the midline is at 2.5, which is D. And then the distance between the midline and the max or the min is the amplitude, and that's also 2.5. So if we wanted to sketch this graph, at 0.01 we hit 5, the midline's 2.5, and the minimum's 0. So midline, 0, midline, back. And we only want a cosine function, it says, I think, somewhere. Oh no, write I as a function inside. So let's write both. So then what is this point here? This is 0.01 plus the period, 1/60th, divided by 4. 0.01 plus 1 over 240. Now you could leave it like that, or you've got a calculator. 0.01 plus 1 over 240. I don't want to round this, so math fraction. 17 over, now wait, I thought I had, let's see. I thought I had something different on my key. I don't know. I'll have to double check that. But yeah, this should be, the period is 1/60th. We divide it by 4. Add that to 0.01. That all seems right. So 17 over 1200. I'll have to check the key that I posted on that. All right, so if we are writing a cosine curve, this would be y equals 2.5 times the cosine of 120 pi times t minus 0.01 plus 2.5. If I want to write a sine equation, starting here, it's a negative sine equation, so negative 2.5 sine 120 pi I need to double check this amount, but T minus 17 over 1200 plus 2.5. And because I'm not quite sure on that shift, because I just remember getting something differently, I'm going to use my cosine function. Plus, it's easy for us to make silly mistakes. So why not use the shift that they gave us in the problem to make the prediction? So what is the current at t equals 0.3? So what is y of 0.3? All right, so again, making sure I'm in radian mode, 2.5 times the cosine of 120 pi times, we're trying to predict 0.3 minus 0.01 and add 2.5. 0.477. And the measurement on y is amperes, which is just amps. All right. So that finishes our 1 through 8 for today. And tomorrow we're just going to practice some more of these on the other side.